Hello everyone, welcome to my next tutorial related to the BDF software. It is a software which used for the quantum chemistry molecules simulation and they totally designed for the molecule simulations. I am Sahil Verma working as application engineer in the Impulse technology. We are going to discuss in here BDF software. As you can see, different products that available in the Impulse technology, and we are working as a distributor parts, and you can see our partners AJW, Nano Academy Technology and Fluxim. And in here we are going to discuss about the quantum chemistry software tools like BDF and advanced quantum chemistry software for the molecular calculations and electronic structures analysis parts. We have already seen a lot of the lectures related to the nanodecals and as well as nano schemes and solar cells and OLED. It is a Fluxim developed software. Basically, we will be focusing here the BDF softwares. It is an independent and complete and distinction quantum chemistry computing software package that very good for the electronic structure of the element systems calculations. And as it is a world first fully relativistic density functional program that have, and they basically calculate a total energy of the ground states of molecular systems. So they are different from the other software due to the fully relativistic density functional program that have, because most of the softwares they are not truly relativistic calculation they do, but the video softwares it is designed for that heavy element calculation as well as. And you can see BDF softwares can be installed Linux operating system, high performance computing clusters, and in Windows they are compatible with the GUI, but for the BDF engine, you need to the Linux systems. You can connect with the Linux because the calculations will run as a Linux, but you can visualize and GUI and set your molecules parameter in the window. Some highlight you can see for the BDF softwares, like it is a high precision relativistics methods and symmetry of any point groups. That means it supports all point group symmetries for the versatile applications. The bottom up self-consisting field approach, efficient orbital localizations, and sublinear scale time-dependent density functional probe methods. And in here you can see sublinear scale chemical shift calculation methods, spin match time-dependent density functional method for the open cell layers, ground state and excited state spin orbit coupling calculations you can do, ground state, excited to excited state, non-adiabatic coupling matrix element also you can do, optimization of chemical structures and reaction pathway. That totally means they have the different unique and distinction features from the other softwares. And it is a totally highlight that given in the user manual. So each of the tabs they have defined one by one. So in here we will be discuss single point energy calculation. So I will take one of the example and simulate their single point energy calculations. How you can do I will show in the tutorial parts. It is just some point related to the video that I want to show you. But now I'm going to open device studio and then I will take one of the example and I will show how you can simulate single point energy of your molecule. It is a graphical user interface device studio and many softwares available on this you can check nanodecal, nanoschemes, rescue, BDF. But when you want to create your new projects, so you can use these tabs. You have already seen this type of graphical user interface in the nanodecal and rescue softwares. Who has not seen it, so they can visit device studio tutorials and nanodecal and rescue. I'm going to take one of the examples, coronin, and then I will show how you can simulate single point energy of this molecule. Before of this, you can import any one of the molecules like this 0D, amorphous, crystalline, and you can see the format they have supported. When you click on the new project and you can give any other name of your project, coronin, and click on this. You can also click on the molecule and take different type of molecule structures, and you can also create by your own selves, add terms. So it depends on the users, and when you click on the molecule 2D, you can also create different type of molecule structures. So it depends on the user which type of molecules they want to create or export. So different formats you can use. As we consider this molecule structure, click on this, and when you click on the apply data, so the molecules have been imported in here. You can check, and it is a graphical user interface where you can take inputs and structures you can create in here, but calculations will run on the BDF engines like Linux system, so you can connect with the Linux system, and you can check on the putty. You can run your project in here. With the help of WinSCP, you can export your project's result directly. Like you can export from your project from this to your system. When you click on the simulator, like you have imported one of the coronary structures, and we are going to calculate in here the single point energy for this molecule. So click on the BDF. You can check job titles, input files, different calculations types you can see. Single point optimization, frequency, optimizations plus frequency, time dependent density functionals, and TDFT spin orbit coupling, TDFT non-adiabatic coupling, TDFT optimizations, TDFT frequency, TDFT optimizations plus frequency, NMR and IRC. So different calculation type you can see in here, and it depend on the users which type of calculations they want. So according to that, they can arrange your scripts. Hamiltonians you can see non-relativistics, ECP, and different Hamiltonians they have given. Method you can check in here the Hartree-Fock, Combs-Sams, and MPV2. Different functional groups they have given in here. It for the accuracy point of view, you can check different functional group. Same for the basic set. You can check, and this is that basic set that I've given. So which type of basic set you want to select for the accuracy point of view, you can select, and charge positive or negative for that molecules. If they are neutrals, you can select 0. Multiplicity, that means 2s plus 1. Like if you take 2s plus 1, so yes, that means total spin. And if they have paired, so yes equal to 0, so it will be 1. Like H2O, they have 2 into 0 plus 1 equal to 1. For the one unpaired electrons, you can select x equal to half, or two unpaired electron, yes equal to 1. So it depends on the users which type of multiplicity they want to choose, and you can check on the solvent. Different solvent they have given. You can check that if you want to include any solvent effect, so you can include. And for this point group and symmetry, like a molecule symmetry that using or not using, so you can choose, and according to that symmetry you can fast your calculations, because when that systems recognize your molecule symmetry, so it will reduce your matrix size of that calculations point of view. And when you click on the XCF settings, like initial guess, you can check atom H core Huckles. You can choose maximum iterations. That means it will iterate your XCF 100 times if they are not converse, and different convergence threshold you can check: very tight, tight, default, loose, and very loose. Damping, Fermi sparing temperatures. So you can choose according to your project which type of calculation you want to do. And in here you can check print molecular orbital. Different orbitals they have given in here. Energy and informations, all informations. Like it is a fragment localized molecular orbitals for the big molecules or small molecules. So you can choose. And when you go with this, like restricted and unrestricted, like restricted for that closed cell system calculations and unrestricted for the open cell system type of calculation. So you can choose and use dispersion corrections and van der Waal interactions if you want to include. It will good for that organic molecules and use IOISCF that help to increase the XCF convergence and their calculations, and it will use for the localized molecular orbitals that help to calculate the bond analysis. So if you want to change any settings, so you can do it depend on the users, and then you can click on the previous scripts and you can check that scripts and settings. I'm taking the default parameter. I'm going to calculate single point energy calculation. If you want to change, you can change. Click on the run button like this. Help of putty, you can click on the list like ls. You can check the molecules. You can add with the directory cd and molecule. Click the tab. Again, you can check ls. Click. And you are running on the Linux systems. These are projects. You can give any other command as well as BDF dot input, BDF dot out, and click on this enter button, and calculation has been started. Calculation has been finished, but before of this, when you click on this open with, you can check different coordinates and geometry point of given, and you can check in here the compacts. Basically that BDF calculations will run at the module wise, like first as the compass, that means which type of molecules, symmetry, coordinates, structures you have selected, so, and then they will calculate according to that rotations one by one, and after this like basic set it will represent the electron orbital mathematical functions and group and symmetry, and then it will jump on the Geon modules where the calculations single or double in electron integral, then XCFs like charge, restricted constant methods, spin multiplicity, DFT, functional group. So then it will represent the further calculation one by one. It is also the tables, and then you can visit on this WinSCP. When you click on this and you can collect your results, coronin, you can see different file has been created in here. BDF.xcf orbitals. It is a readable files and binary files, different files and output files they have given. You can copy this, check on your project and paste. Click OK like this. Now you can check your result. BDF.output file. You can see show atomic number, show atomic symbol, charge number if you want to see for that every atom. You can check. Show length bond. You can check. Not only this, if you want to move with further calculations, you can do like multi and loading, and you can apply data in different files with the help of this result or data you can use. And in here you can check summary of this total energy like Harty and electron volt. As 1 Harty equal to 27.2114 electron volt, and energy in here the negative, that means electrons are bound to the nuclei, and if they have more energy, so that means the structure is more stable. Molecular orbital structures, and the calculations not coming here for the TDFT because we not going this TDFT result. After this tutorial, I will show how you can calculate time-dependent density functional theory results. And when you go with this BDF XCF files, you can see alpha and beta. So alpha that means closed cell system calculations. Alpha and beta that also can be say it in the quantum chemistry every electron have the two spin like alpha and beta spin. And in here only showing the alpha that means beta is empty as we consider and virtual that means they have some empty space in the orbital and it is irreducible representations and every orbital they have the some energy you can check one by one but at this side you can see red and blue representations that means red in here the positive and blue for the negative it showing that electron density at the sign phase it is not showing for the charge it is just can be say wave functions phase and if the orbital they have a fill so you can see they are stable and energy they also be negative in here so they have stables though not any space that given in here. You can check one by one for that every if transparency you can also see like this it's just for the representation but at the bottom side you can see alpha homo energy and alpha lumo energy that means if you want to calculate energy gap so it will equal to energy lumo minus energy homo. So you can calculate for this and you can check LUMO, HUMO gaps in here. It is 4.61 electron volt. And if you want to save that file, so in the image form you can collect your result. So orbitals and wave functions representations you can check. Like in the alpha and beta, if you not choose in here like 1 minute BDF restricted and unrestricted. So they will show both alpha and beta. So it depends on the user for that closed cell system calculation or open cell system calculations. Now I'm going to end here my tutorials. In the next tutorial, I will discuss about the time-dependent density functional theory parts and UV visual spectroscopy results and number of the products and software that given in the impulse technology. Who has not seen it, so please check out that. Thank you very much.